All right, in the last video we talked about the three ratios for right triangles. Let's talk about how we use those. So if I had, for example, a right triangle, let's have it look like this. Yikes, that's not a straight line. All right, so here's my right angle. And let's say that this side, let's call this side 5 and give this an angle of 38 degrees. So if I only know about this, if I only know these two bits, I can figure out the rest using my triangle relationships. Obviously, this angle up here is going to be 90 minus 38. I don't really need to know that, but I could. So 90 minus 38 would be 52 degrees. So let's add in our new information in black. And now we need to find one of these two sides. So I'm missing the hypotenuse and I'm missing the adjacent to 38 or the opposite of 52. So let's go ahead and find the hypotenuse. I'm going to call that one h. Okay, so we know that sine of an angle is equal to the ratio of the opposite over the hypotenuse. So sine of 38 is going to be 5 over h. Well, I could also use the 52. The 52, I could have sine of this over h, but I don't know this side, so that doesn't make sense to use. With 38, cosine would also be this missing one. That doesn't make sense to use. But with 52, I have the adjacent side. I have the side touching. So I could also say that cosine of 52 is equal to the adjacent over the hypotenuse. So either one of these I could solve. So let's solve the first one. Multiply h to the other side. Solve for the h. Or I could have used the cosine relationship. And those are all angle measures, always within sine and cosine. It's the input is an angle. So let's put those in our calculator and see if we get the same answer. We could say that either one of these is the exact value, but now if we want the decimal approximation, we should end up with something that's bigger than 5. Let me just escape out of this. Okay. Yes, thank you. All right, so let's first of all make sure that our calculator's in degree mode. Mine right now is in radian, so I need to go down and change it to degrees. I'm going to come back to the home screen. So we had 5 divided by sine of 38. And we also had 5 divided by cosine of 52. And we get the same answer. So either way, that side h, we wanted it to be bigger than 5. It's the hypotenuse, and it is. It's about 8.12, whatever our units are. So using these ideas, we could also use triangle trig to find missing angles. So let's look at an example where we're missing an angle. So again, we have a right triangle. Let's call this side 4. This side looks like it's 6. So I could use Pythagorean theorem to find my missing side. Similarly up here, once I had that this h was about 8.12, I could use Pythagorean theorem to find my missing side. Or I could have used now cosine of 38 and used the h. But if I want to find it exactly without using these rounded numbers, I could also use tan. So notice we could say tan of 38 degrees is equal to 5 over our missing side here. It's the adjacent of 38, it's the opposite of 52. So I could also say tan of 52 is equal to x over 5. This is a nicer one to use because now x is 5 tan 52. So 5 tan 52 Okay, so we get about 6.39. If I square that and add 5 squared, and then square root that whole answer, whoops, square root that whole answer, notice I've got the same number. So Pythagorean theorem or using my calculator, we're going to get the same value. All right, so coming back down to this one. I could use Pythagorean theorem to find this side, but if I'm looking for the angles, I'll call this one my theta. So tan theta is equal to 4 over 6. Well, if I want to get the theta alone, now I know the ratio, I don't know the angle. To find the angle, I need to inverse the operation. And on my calculator, I do that with second tan, gives me tan inverse of 4 over 6. My angle is about 34 degrees. So theta is approximately 33.7 degrees. So that's how we use SOH-CAH-TOA. In the next video, we're going to look at special right triangle relationships.